Hello everyone, this is Marhaba here again. We are now on lab number 5 in this course, and we are still working on the load balancing on OSPF. Before I start going through all the points of the labs here, let me first show you what is the lab diagram. As you can see over here, we have two routers in the backbone area, router 1 and router 2. They have two links connected to each other on Ethernet 1 on both routers, and on Ethernet 2 also on both routers. Ethernet 1, it has an IP address. The link of Ethernet 1 has a subnet of 192.168.12.0 again. Remember, I say 12 because that's router 1 to router 2. And on Ethernet 1, it has the .1. On Ethernet 1 of router 2, it has .2. And also, router 1 and router 2, they have also another link connected to each other on the Ethernet 2 interfaces, 192.168.21. And here is .1 and here is the .2. And then I have created two bridges on router 1 and router 2. They have 11.11.11.11/24 on router 1, and here 22.22.22.22/24 on router 2. So this is the lab scenario. What we are going now to do, we have to enable OSPF on both routers, on router 1 and on router 2 also, after we have the IP address set. And then what will happen, we have to see how router 1 can reach this network over here, from which way, if it's going to take this way or if it's going to take this way. And then we are going to play a little bit with the cost, so we can choose router 1 to go from one route and not from the other route. Okay, so this is what we are going to do in this lab. Let's go now and see point by point what we have to do, and then we follow them one by one. Okay, this is the lab scenario over here, the 6 points that we have to go through. But before I start, and as always, I would like to put first the lab scenario here on the top right of the page, so you can follow the lab in a better way. Okay, point number 1. All IP addresses are already configured as on the picture, including the bridge interfaces on router 1 and on router 2. Okay, so I have already put all the IP addresses as on the picture just to win the time, because it's very easy for you to know how to put IP addresses. Point number 2. Enable OSPF on router 1 and advertise the connected interfaces. Okay, let's go directly to router 1. And we need to advertise the connected interfaces. I have to go first to routing, OSPF. I will put the router ID 1.1.1.1. And then they ask us to advertise the connected interfaces, and that's something we can do it from network here. The first interface is the bridge interface, which is 11.11.11.0/24. It's inside the backbone area. We don't have any other area, so you can see here as the default one, the backbone. And then we have to advertise 192.168.12.0/24. That's the backbone area. And then we need to advertise 192.168.21.0/24, also on the backbone area. So this is done. Now, point number 3. Enable OSPF on router 2 and advertise the connected network interfaces by one command. Okay, that's something new. We haven't seen it before. Actually, let me just show you how we can do that. We go to router 2, then we go to routing, OSPF. Again, we put the router ID here, 2.2.2.2. We can, inside the network over here, instead of putting each network by itself inside the OSPF process or to advertise it, what we can do, we can just say plus, and we can say network 0.0.0.0/0. That means all our interfaces which are connected to this router, they have an IP address, then we need to advertise them inside OSPF. I don't advise you to do that, but that's only to show you that there is a way also to do. Say you have a lot of network, then what you can do, you can just say network 0.0.0.0/0 inside the area backbone, and then you say okay. And by this, what we are doing now, when we do this, we are advertising actually on router 2. We are advertising this network, we are advertising this network, and we are advertising this network. Okay, and that's what they ask us to do here. So point number 3 is done. Enable OSPF on router 2 and advertise the connected interfaces by one command. And then check if the routers have formed neighborship and the routes are added. Let's go first to router 1. We check if we have neighborship, and indeed, router 1 has formed neighborship with router 2 via both links here, 1.2 and 2.1. And we have to see the routes. So router 1 now, he knows how to reach the network 22. Okay, if you want, we can go to IP route. From here, IP routes. And you can see that he learned from OSPF how to reach to the network 22.22.22.0. Okay, so router 1 has received a route from router 2. We go also to router 2 and we check as well. Now we are inside router 2. Neighborship, indeed, there is neighborship with router 1. And we go to IP route. And over here also we see that router 2 has learned from OSPF how to reach to the network 11.11.11.0. Okay, so point number 4 is also done. Point number 5. Which route can router 1 use to reach the network 22.22.22.0 and why? Let's see. We go to router 1 and we go to IP routes, and we see here that router 1 is able to reach the network 22.22.22.0 via the gateway 12.2 and via 21.2. If we look back to the graph over here, so router 1 is able to reach this network over here by sending to the gateway this and this. That's 12.2 and 21.2. Okay, that means you can use this link and you can use also this link to reach to the destination network. And now they're asking why he's using the two links and not only one. And here, remember when we were talking about the cost. If I go to router 1 here, let me close that, and then I go to routing OSPF interfaces. Okay, we go inside the interfaces Ethernet 1 and Ethernet 2. We see that inside the Ethernet 1, if we double click on it, this has been added dynamically because we advertise the network, then it directly will be shown here. But we see that the cost is 10 on Ethernet 1. So I will put that here on my picture here. Okay, we just clean a little bit. Okay, so here it has a cost of 10. Okay, on Ethernet 1 of router 1. That's what we've seen here. Ethernet 1, cost of 10. And Ethernet 2, it has cost also of 10. Then this one has a cost of 10 also, Ethernet 2. Now I go to router 2 and I do the same. I go to routing OSPF interfaces, and Ethernet 1 has a cost of 10. So Ethernet 1 has a cost of 10, and Ethernet 2 has a cost of 10 as well. Okay, so if we look here, we have 10 plus 10, 20, and here we have 10 plus 10 is 20. Okay, if we go to router 1 again, and we go to route over here, okay, we can see that router 1 has mentioned here inside, we are inside OSPF route, okay. He mentioned here that to reach the network 22.22.22.0, he can go via Ethernet 1 and via Ethernet 2, and both of them, they have a cost of 20. Okay, because both of them, they have a cost of 20, so each one has a cost of 20 actually. In this case, they have equal cost, and as we said, OSPF works as equal cost load balancing. That means he will add both routes inside his routing table, and that's what happened here. If we go to the graph, we see 10 plus 10 is 20 in this link, so we have total 20, and here we have a total of 20. Both are equal. Then router 1 will say, okay, as they are equal cost, both of them, then I can use both of them to be able to reach this network over here. And then what he will do, he will add both of them inside his routing table. And that's what happened here. When we go inside IP route, we can see that he has added both of them inside his routing table. If we double click here, you can see that he's saying the destination network to 22.22.22.0, he can go on the gateway 12.2 and 21.2, which is reachable on the Ethernet 1 and Ethernet 2. Okay, so this is really the explanation why router 1 has chosen the two routes to take him to the network 22.22.22.0. Now they're asking us to make the change needed so router 1 can reach the same network via the link of Ethernet 1 and only Ethernet 1. Okay, so what we need to do now, we have to make something here in the configuration in a way that the router 1 will only use this way on Ethernet 1 to reach to this network. Okay, we don't want that he used that path anymore. Okay, just to remember that the lowest the cost, the better the route is for the router. Okay, here we've seen that we have 20/20. So what we can do, we can lower the cost here. Instead of being 20, we make it less than 20. Then in this case, directly router 1 will go from this route. Or what we can do also, we can hire this cost over here, the total cost. Then at the end, the link which is from router 1 to router 2 on the 192.168.12.0 should be lower than the other cost of the other network in order to be able to use it to reach the destination 22.22.22.0. Okay. What I'm gonna do now, I will go to router 1, and here how we can change the cost. I go inside routing, OSPF, interfaces. Here, those two interfaces have been added dynamically. I will have to add it manually, Ethernet 1, and inside of here, instead of having 10, which is the default cost given by MikroTik, I make it 5. I click OK, and then here I can make the explanation what I've done. So that's what we had before. Now I made this one 5, the cost 5. Then 5 plus 10 will give me 15, and this will stay 20. 15 is less than 20. Then router 1 will put this inside his routing table, this route over here. Let's justify this. I will go to IP route. And as you can see now, he took out the second route, and he only put that to be able to reach 22.22.22.0, it has to go via 12.2, and that's really what I have done by changing the cost. He's not showing me anymore to 1.2. Okay, and if I want to go now to routing or SPF, and I will go to route over here, we can see here clearly that the cost here is 15, and that's going from 1.2.2, which is on the Ethernet 1 interface. And that's really clear for me now that the router is using now that link. Something to say here, that in case this link goes out, for example, this interface possibly is disconnected, then this one will make, let's say, the failover, but again, it needs to do an SPF algorithm again, okay? So the router needs to recalculate again to be able to find another route, but then at the end, this will be shown. Okay, if you want, we can check it, but let's see first if we still need to do anything else here. So make the change needed for R1 can reach via Ethernet 1, the destination 22.22.22.0, so this is done. Now, I will do this point also. What I will do now, I will go to router 1, and I will go to the interface here on Ethernet 1, that's the one we are using now, and to send the route to 22.22, I will make it disable, okay? And then, now we go to IP route, and we can see now directly that router 1 is saying to reach 22.22.22.0 to send the packet to 21.2, which is again Ethernet 2. And that's what we have here in the graph. Because this one is now disconnected, this internet, that means this link is off, then he's using now this one. Okay, and if we go to routing OSPF, we can see here that it has a cost of 20, but there is no any other lower cost than this because the first one is now down. Then in this case, this is inside the routing table now, even if it's 20, because it's the best at this moment. Okay, so the lab is now finished, and this is how now we can play with the cost in order to make the load balancing on OSPF. Remember always that load balancing on OSPF works only if we have equal cost. If we don't have equal cost, we are not able to do load balancing. And changing the cost, it happens inside the interface inside the OSPF. But you need first to add it manually, and then you can change the cost over there, and then you calculate the sum of the cost. With the one which has the lowest cost, then is the route that will be used and will be added inside the routing table. I hope that this lab was informative for you, and I see you in the upcoming